Today, you're going to learn about inverse functions. I love inverse functions. They make so much sense and they bring a lot of the math together. The notation that we'll use for inverse functions is f inverse of x. And hopefully you heard how I said that, f inverse of x. So what are inverse functions? There are two functions that can undo each other. And remember, undo is just a fancy way of saying solve. In other words, they are instructions for solving one another. So here are two inverse functions. I've given them different names. However, you'll usually see one of the functions called f of x, and the inverse will be called f inverse of x. These would be inverse functions. So if two functions are inverses, they'll tell you how to unfold each other. If you look at f of x, this says multiply x by 2 and add 8. Well, if we wanted to get x by itself, we would say, first we're going to subtract 8 and then divide by 2. And that's exactly what g of x is doing. It's subtracting 8 and then dividing by 2. So you'll kind of see the reverse in the order of operations and a lot of good stuff going on here. Just as well, if you wanted to solve g of x and get x by itself, you would first multiply by 2 and then add 8. And if you look at f of x, that's exactly what it does. It multiplies by 2, then adds 8. Anyway, let's kind of see how this is going to work. I'm going to first show you how to run a test to see if two functions are inverses. So, f of x is 3x minus 4. G of x is x plus 4 equals divided by 3. So let's see if we take this function and insert the whole thing in for x, let's see if it unfolds and we just get x. So I'm going to take x plus 4 over 3. And I'm just putting it right here for x, and then subtract 4. Let's see if we simplify. Yep, we just get x. But now, here's the test, the big test. What if we go the other way and take all of this and plug it in for x? Let's see. So I'm going to start here. And I'm going to take the 3x minus 4 and plug it in. Let's see. We get 3x minus 4 plus 4 over 3. And certainly, we can see everything unfolds really easy. When you go to pre-calc, you're going to see this as f of f inverse of x equals x. And f inverse of f of x also equals x. So you're not finished with this concept of inverses, and you're also going to learn that this only works on one-to-one functions. I don't know if you remember what a one-to-one function is from Algebra 1, but just remember that one-to-one functions pass the vertical and horizontal line test. You'll remember, hopefully, that in order to be a function, you have to pass the vertical line test. And then in order to be a one-to-one function, you have to pass the horizontal line test. Okay. Let's move on and learn how to find the inverse of a function. So let's say you only know f of x. This is going to teach you how to find f inverse of x. Okay. So we have 4 steps. First, replace f of x with y. Then you're going to interchange or switch x and y. Then you're going to solve for y. And then you're going to remove the y and put in f inverse of x notation. I'm going to show you right here how easy it is to follow those steps. So we're looking for the inverse function. So the first thing I'm going to do is put the y in place of f of x. Step 2 tells me to switch x and y. Oops. So notice I put the x where the y was and the y where the x was. It's just a quick switcheroo. Now, the third step says to solve for y. So I'm going to get y by itself. Divide by 2. And now, instead of leaving it as y, we're going to replace y with the f inverse of x notation. So now we know that the inverse for this function is this function, and they would undo each other if we plug them in to each other. I want to give you a quick warning. A lot of people see the negative exponent and mistake it for a reciprocal. It is not. This is just notation that means inverse function. So please do not mistake that for reciprocals. Alrighty, let's see if we can follow those 4 steps again to find the inverse of this function right here. So remember, first, we're going to put the y instead of the f of x. Now, as we're working this out, you see a square root. So I want you to, first of all, think, well, we undo square roots with squares. So our answer should have a square in it. Now I'm going to put x in place of y and y in place of x and try to get y by itself. So I want to get rid of everything on the side and isolate the y. So I have x plus 1. Next, I'm going to divide by 2. And now, how do we get rid of the square root? We square both sides. And we want to be very careful. The square and the square root cancel out. So over here, we just have y plus 3. And over here, be careful. When you square the numerator, that's going to be x plus 1 times x plus 1. And then when we square the denominator, that part is pretty easy. Let's come up here where we have a little more space. So in the numerator, we have x squared plus 2x plus 1. And in the denominator, we have 4. Now y is almost by itself. I just need to subtract 3 from both sides. So here I have y. But over here, I need to be very careful. These do not have the same denominator. So I want to make sure that I get a common denominator before I try to add those. So I'm going to call this 12 over 4, just multiplying top and bottom by 4. And now I have x squared plus 12x plus 1 minus 12 over 4. And notice I'm just getting a little more comfortable. I prefer my y on the left. And now I'm going to combine those like terms and I'm done. And I'm going to go ahead and put in the proper notation. Never leave the y over here. Remember that step 4 tells us to put that f inverse in there. So my numerator is 2x minus 11 over 4. Alrighty, and as you can see, we've employed some of those skills that we've already learned with binomials and combining like terms. Let's look at example 4, and this is our final example for today. It says that we're going to find f inverse of x first. So let's go ahead and do that. And this is great practice. You can't do it enough in math. Practice, practice, practice. Like I always tell you, watching me work problems will not make you a good problem solver. I watch Serena all the time, and I still can't play tennis. Okay, so I'm just going through my steps. Y is by itself, so f inverse of x is x plus 5 over 3. I'm going to split this. And the reason I'm going to do this is because I already know I'm planning to graph this. So I want it to look like slope-intercept form. That makes it a little more easier to graph. So I'm going to start off by graphing this one. That was my original function. I'm going to put it in blue to make it a little easier to graph. So I'm going to start at negative 5. 1, 2, 3, 4, 5. Up 3 over 1. Remember how to graph those lines. And let's try to make this one a little neater than I would normally do it. So there's f inverse. That's f of x, actually. And, with f of x, I'm going to go ahead and label that f of x because that was our original function, f of x, and that's what we were told to graph. Now I'm going to go ahead and graph f inverse of x, and let me make that one yellow, or golden, I should say. So I'm going to start at 5/3 on the y-axis, which is what 1 2/3 approximately there. And I'm going to go up 1 and over 3, up 1 and over 3, which is approximately there. And now I'm going to graph those. I'm going to draw a line through those points. And we have f inverse of x. Now, I'm going to tell you the way I know if I've graphed my inverses properly, and I hope you hear me on this. As a matter of fact, I'm going to change colors again. I'm going to use this hot pink so you can remember this. Inverse functions reflect in the line y equals x. So I'm going to just do a dotted version of y equals x so you can see what I mean reflect or mirror. Y equals x has an intercept of 0 and a slope of 1, up 1 over 1, up 1 over 1. Okay, and if I were to do a dotted version, I think this makes it, my line's not good. Let me go back and fix that a little bit. I didn't go through those points very well. Now, if you look at that, you can see that the blue line and the gold line do mirror one another. You're going to see as you practice tonight for homework that all of your inverse functions will have that mirrored effect. For example, the cube of a function and the cube root, you'll see, will have that mirrored effect. You're also going to notice that tonight we know square and square roots are inverse functions, but something happens. A parabola is not a one-to-one function because it does not pass the horizontal line test. So what we're going to end up doing is only looking at, we're going to restrict the domain, and you're going to see that so that you're also going to see that the inverse is the square root, and you'll see that reflection. So I want you to be aware that all the inverses reflect in the line y equals x.